I, Mr. Shivendra Acharya, Head of the Department of Physics, U.V.K. College, I have to state the transport phenomena of gases. Physics, second paper. First part, honors. According to kinetic theory of gases, we know that molecules of gases are in very motion, and motions are in large velocities. Large velocity, we have to say that large velocity means the velocity under the Reynolds number. I mean to say 2000 minimum, than 2000 it will hold the streamline velocity. In viscosity you have learned streamline velocity of molecules. Now the question raised is transport phenomena मिटाने वाला नहीं, phenomena of molecules in gases. Kinetic theory states about it, molecules of a gas move, and movement is very large. Even at ordinary temperature, frequently they collide one molecules to another. We suppose that vessels and gases, molecules of gases in all directions. Directions are when it collides to the vessel, it gets returned. But when one molecule collides with another in such direction, kinetic motion ठीक हो रहा है
जी हाँ
kinetic motion when their speeds and directions changes since the molecules exerted no force on another except A does not exerts force on B and C does not exerts a force on D. In this case, a new topic raises in this transport called mean free path. When molecules center of C and molecules center of D is measured in terms of transport, we see that mean free path when it is upper than Reynolds number, that is a turbulent force. Second term, a series of single molecule. If you suppose that a single molecule P a path called zigzag path develops, a zigzag path develops, and this path we know that mean free path is defined as the average distance traveled by molecule between two successive collisions. Collision successive means if the direction is just opposite to the direction of another molecule, then a collision heads at any point, and this point is within the distance of mean free path, within the distance of mean free path, and we get a successive collision. Gas molecules have a finite diameter. Gas molecules may be spherical, maybe not. Particles may be spherical or in any case maybe not. In such cases, we see that molecules of the vessel enforce, exert a force on this wall, exerts a force on this wall of the vessel, such that the molecules collisions cause molecular to moleculate also a zigzag path. Molecules so collide mutually leads the conclusion that they have finite size, must have finite size. A finite means that geographically we can define it geometrically. Geometrically we define then center of gravity. We have learned in earlier classes. Center of gravity, if we suppose that a triangle a center of gravity, we may say that the center of that molecule. Then, in that case, if it is not spherical, then this length, the length between a center to another center will be called the diameter of the particle. Will be called the diameter of the particle. D of the particles. Now we have to start the question. This topic is phenomenal transport of molecules in gases. So kinetic theory is the base point, has the fundamental original point, the point to be caused of the phenomena is kinetic theory. Molecules, gas move constantly in various speeds. Speeds may be in all directions. Speeds, we may say that mass, velocity, temperature, molecular concernings, and part of the gases another than moving molecules transport velocity depends upon the rise to velocity, conductions and diffusion. 3 points may be defined well. First of all, we will say about viscosity. The different part of the gas may have different velocities. If so, there will be relative motion of the layers of the gas with respect to another. In such a case, the layers moving faster impart momentum to slower motion. Layers to bring in equilibrium state. Faster motions and slower motions, these layers always tends to get the equilibrium state. This gives rise to phenomena of viscosity. If the different part of the gas may have different molecular concentration. Suppose that number of molecules per unit volume. If so, the molecules of the gas will carry the mass of the regions of higher concentration to those of lower concentration to bring the equilibrium state. This gives rise to phenomena of diffusion. The different of the parts of the gas may have different temperatures. If so, the molecules of the gas will carry kinetic energy. The different part of the gas may have different molecular concentration. Molecules of the gas will carry the mass of regions, the mass will of those lower concentration, and these concentrations phenomenon is diffusion. Let's just consider a mass of gas moving in parallel layers between two horizontal planes AB and CD. AB two layers AB and CD. And between this and suppose that the velocity of the layer of the gas in contact with plane AB is 0. In contact, 0. and increases as we go towards the plane CD. Let us consider an intermediate plane MN. The layer of gas above plane MN are moving faster than that of the layer gas below the plane. It is faster than that of this plane. It moves faster than that of this. The faster moving layers exert a tangential force on the plane MN and increases in velocity, whereas the same time layer below MN exert an equal force in opposite directions. Equal force opposite to one another. Now explanation of the viscosity on the basis of kinetic theory. सुनिए, दिखाइए एक बार.